So, as always, as physicists, what do we have to do? Put formulas, do math. That's what it looks like. I strongly suggest that you guys write these down or in some way, shape, or form know them. You can easily confuse them, but they're basically divided into two categories for our convenience. So I've made them into a source moving or an observer moving, because those could be the two possibilities. Either the source moves or the observer moves. So when the source moves towards the listener, and then again, it could be two possibilities. You're either moving towards each other or away from each other. So when a question is given to you, first note whether it's the source moving or the observer moving. And number two, then notice whether they're saying they're moving towards each other or away from each other. Okay? And then find the right formula that goes with it. So for example, if the source is moving towards the listener and V is the speed of sound, and Vs is the speed of source, then use these formulas. FL is the apparent frequency that the observer will observe. Fs is the frequency by which the source is emitting. So Fs is the source frequency. FL is called the apparent frequency. So notice something. These two formulas are kind of the same, except one has a minus and one has a plus. These two formulas are kind of the same, but one has a plus and one has a minus. That accounts for the fact whether the source and the observer are moving towards each other or away from each other. Those two account for that. Remember in vector additions, we were like, if it's moving on this side, add a plus. If it's moving on that side, add a minus. So for our case, all I need you guys to remember is these formulas. So when you're given a question, look for whether you're going to be, so imagine, let's call this case 1, 2, 3, 4. So look for A and B first, whether it's the source moving or whether it's the observer moving. Then look at whether they're moving towards each other or away from each other and use the right formula. What if they're both moving? I just want you to know these formulas. So for example, if both of them move towards each other, use this formula. If both of them move away from each other, use this formula. If you notice that the only difference between them, very carefully, is where the minuses and the pluses are formed. So write those down, keep them with you. Pardon? VL is the speed of the observer. Vs is the speed of the source, but in this case, they're both moving now. So we have to differentiate them. Okay, now here's a question. An ambulance producing a 3,000 hertz tone is moving towards you with a velocity of 50 meters per second. What is the sound frequency you hear? And number two, what is the shift in the frequency? Now, going back to your four formulas, we have to figure out what we know and what we need to know. So what's the frequency of the source? 3,000 hertz. And what's the speed that it is moving with? 50 meters per second. So what are they asking you to do? Find FL. And under normal conditions, the speed of sound is 344 meters per second. give or take. Sometimes also people write 343. It's either one is fine. 344, 340. So out of these cases, which is it? Yes? A1. Good. It's the source moving and it's moving toward. So what was the formula for A1? FL equals FSV over V minus VS, which will be 3,344 divided by 344 minus 50. Anyone have an answer? Yes? 3,510 something, right? And then it asks me, what is a shift in the frequency? So that will be my delta F. What was it? 3,510 minus 3,000. That's the shift. And it is 510 hertz. So anytime it asks you for like a shift, just do that. Okay. Part 2. Now the ambulance crosses you and heads down the road. What is the sound frequency you hear now? What case would that be now? A2, right? Because the source is still moving, but it's now moving away from you. Do you see how these questions are done? So this would be case A2, and the formula for that one should have a plus with it, right? And since this is going away from you, I predict that the value will be lower. Frequency should go lower. Yes. 2,610 hertz. Good. And what will be the change in frequency now? Remember, the original was 3,000. So we're doing it with respect to 3,000. 300 and... Thank you.